Hi, my name is Alexander Kim and my partner is Ananya Mohanraj, and we will be covering the question, is there a connection between frequency and enjoyment in music?
In this day and age, music is arguably more widespread and diverse than most, if not all, periods of human history. Our project revolves around music as we ask, is there a connection between frequency and enjoyment in music? We decided that this was a good topic to cover, as both of us have decent amount of knowledge in music, and we could easily use the numerical values of frequency to apply mathematical knowledge to find an answer to our question.
We could easily search up frequencies for notes, but to get data for enjoyment, we would need to create a survey for people to rate pieces structured around frequency. We got Eva Ledvina, an oboist, and Luke Baxley, a violinist, to play these pieces. For the survey, we decided to use a basic 1 to 5 rating scale to rate 5 pieces. Each piece was composed by me and had a range of 4 notes, and 2 notes from the previous piece would overlap into another, creating a total range of B below the scale and F above the scale. This total range was chosen to fit the instrument with the smallest note range, the oboe.
The measures that are displayed were composed by Alex. For each piece, the frequency range and average is displayed. It is important for us to take into account that piece 1 and 3 have a significantly lower frequency range. After receiving a total of 65 responses, these were our results. Piece 1 and 3 received a significantly lower amount of points than the rest of the group. If you notice from the previous slide, these pieces are also the ones with significantly lower frequency ranges. Because of this, we can assume that there is a connection between the range of frequency in a piece and the general reaction towards it. So the next question to ask is what the rating would have been if we had the largest possible frequency range. The largest possible frequency range that we can get from the site we are using to obtain frequency values for notes is 7,885.7 Hz, which is from C0 to B8. To give you a perspective of how extreme this is, the total note range in our survey was from B3 to F5, or 451.5 Hz.
In order to do this, we decided it would be best to use linear regression. By graphing the relationship between the range of frequency and the rating, we can plug in the frequency range we want into the x value of the line's equation to predict what the rating would have been.
The formula for the slope of linear regression is m equals the mean of x times the mean of y, minus the mean of x times y, divided by the mean of x squared minus the mean of x squared. The formula for the y-intercept of linear regression is b equals the mean of y minus the slope times the mean of x.
First, it would be a good idea to make a chart for all of these values. From this table, we can find out that the mean of x is 125.3, the mean of y is 193.2, the mean of xy is 24,737, and the mean of x squared is 16,896.1.
To find m, we can plug these values in to get the slope. M is equal to 125.3 times 193.2 minus 24,737 divided by 125.3 squared minus 16,896.1, which is equal to negative 529 divided by negative 1,196, which is equal to 0.44231. Now that we have the slope, we can find the y-intercept by plugging in the needed values. 193.2 minus 0.44231 times 125.3 is equivalent to 137.78, which is our y-intercept.
Now that we have the slope and y-intercept, the equation for our linear regression comes out as y equals 0.44231x plus 137.78. In order to find the projected rating of a frequency range of 7,885.7 Hz, all we need to do is plug in that value into the x variable of the equation. When we do this, we get y equals 3,625.7. But wait, this doesn't make sense because the maximum score possible is 325. 65 respondents times a maximum score of 5, meaning that this does not account for the survey's limitations, but it does give us a tiny insight into what the general reaction would have been like to a piece of this frequency range.
Why is this topic important? This topic is important because by looking into what causes enjoyment in music, musicians have the ability to be more informed on how to increase the quality of their music, and overall allow the musician to appeal to a wider audience of consumers.
There are a few ways we could have improved the project. First off, we could have standardized the pieces even further if we had added in an extra note in the first piece, so that the number of notes throughout every piece would have been the same. Secondly, for the last note in the second piece, the note should not have been a C, as C would have been out of the intended range. Fortunately, the singular note error should not have made enough of a difference to defeat the legitimacy of the survey.
One thing we would have liked to do towards the end of the project was actually open up another survey, so we could have more data to work with and experiment with predictions accounting for number of responses.
Conclusion. From the data given from the survey, we looked into the range of frequency, as there was a significant connection between the range and rating present. We decided to overlook average because pieces 2, 4, and 5 had significantly different averages, but did not have a point difference more than 7. By using the data given, we were able to create a graph, which though is not completely realistic, gave us a greater insight between the relationship of the range of frequency and enjoyment represented by rating. We could have had more data to work with if we had opened another survey, but unfortunately, by the time we had realized this, it was not plausible.
The main point given from this presentation and answer to the original question is simply that the larger the range of frequency, the more appealing it will generally be. Thank you for listening to our presentation, and we hope you enjoyed it.